Hello. So we are live for 1 hour with Hélène Plihon. She's a brilliant geochemist who travel in Brazil, but she's French, and her research is about the mangrove of Brazil and the pollution of the mangrove. I will, of course, let her explain us what are these alien ecosystem on Earth and why they are so important for us. Hello, Hélène. How are you?
Fine, and you?
And thanks for being my guest for this live. It's very important to have you today. Let me just check some technical things to see if everything is good. If you are recording, yes, everything is good. You know, it's always some stress when you launch this kind of event.
Yes.
So everything is perfect. So, Helen, maybe we can talk about a little bit about yourself to make you known to the audience, and see what was your motivation to become the scientist and researcher you are today. Um, Maybe you can talk about a little bit about your childhood. Do you have this science think around you or in you already when you were a child? Did you study things when you were in kindergarten, or is science something has came to you later, maybe at the end of the high school? What was your story?
Well, first, I will introduce a little bit myself. I'm Hélène. I'm 25 years old, and I'm currently doing a PhD, my first year of PhD.
Mhm.
And about my background, science was always all around me because my two parents have a PhD, and
Mm.
my mother is a researcher. But now she's more teacher in university, but she used to do research in biology, chemistry. And my father has a PhD and now he's engineer. And
Mm.
my grandfather was a teacher of chemistry. So
Wow.
yeah, we are like a scientific family. I don't have many artists or many people studying literature, but uh, it has never been like something that my parents want me to do. Like they just talk about science because it was their job, but they
Mm.
never told me, "Oh, science is super nice and you have to do it."
Mm.
And but I think it's because they were talking about science all the time, and it was their job that I was getting interested more and more and more about it.
So you were immersed in this environment when you heard them talking about science, what their job, and you were completely immersed with their speakings and their work at home and etc.
Yes, but not only because also, I mean, they still make me discover other things because, for example, I
Mm.
was reading a lot of book, I was taking theater classes, so I still have other things to think about. But yeah, it was mainly science because, for example, when my mom used to take me with her in her job, well, I was seeing the student, I was seeing the chemistry things, so she didn't do it on purpose, but it was
Mm.
in my head.
Uh, so you naturally followed scientific studies in high school. I mean, and then. You were surely a good student, no?
Yes. First, I think the reason why I study science, why I choose scientific studies, so back S as we I was used to call it in France, it was not especially because my parents told me to do it, but
Mm.
because like you have this thing in France, this injunction about society, which is like you have to do back S. If you're a good
Mm.
student, you have to do back S, else you're closing doors. And
Just let me explain what is BACS. BACS is the diploma at the end of the high school in baccalaureate. It's called baccalaureate in France, and we have three type of or four type of baccalaureate. The Bac S, which is the scientific one, and the other is for those who are good in literatures and humanities, and the third one in economics and sociology, and there are others. But the Bac S, the baccalaureate scientific is the one who open you the doors of the scientific studies, engineering school after.
but not only, and I think this is the sad thing, is like it seems for all people that it's open you all the door, and so
Mm.
even if you're not interested in science, all my friends used to do back S because even if they didn't like science, but just because it's what good people do, and I don't really like these things, but it was really how it used to be back then. Now I don't know with the new new reform, how it's worked. And about being a good student, yeah, I was a good student because I really I used to like to study a lot. And but at school I was really talkative. I talk a lot with my neighborhood, and I was not like the perfect student also. Talk a lot and drawing a lot. I was always drawing on my books.
So I see on your bio that you entered École Normale Supérieure, right? So it's maybe one of the best higher education school after the high school in France, dedicated to science, but also in humanities. They form the best scientific students in France, but there are also other schools. And because I'm a university guy, so also university is very good, guys. Don't, but École Normale Supérieure is very good. So you entered ENS, but why ENS? Um, did you program yourself to target the school, or maybe you wanted to target, I don't know, others, engineering school, or why ENS in particular?
So after high school, I didn't really know what to do. First, I was hesitating between science and doing, because I really love to draw, I really love art. So I was hesitating between artistic career or science. And I choose like the easiest. For me, it was the easiest way because I was really.
Wow.
Yeah, I know that seems, but for me, it was like I was good at science and I was not working that much, and it was doing things were going well. So I knew that it will work. And whereas like art, because I have no artist in my family, it seems so unreliable. It seems really like too much risk for me. And I mean, my mom told me you can do whatever you want, and it's only me, but with also this society that told you that artists are like it's never working and all these things, and you will not earn money, and we. So with these things, I choose science, but I still like science. And then I choose preparatory classes because I didn't feel to go to university, because university you're really alone, like you have to work by your own. And I needed, at 18, I think I was too young to be free. Like I needed someone like a high school system to tell me when to work, and what to study. And I really enjoy this system because I think between 18 and 20 I was not ready to be autonomous. And then ENS, I knew I wanted to do geology because I prefer geology at biology.
So you already have this taste for geology.
Science for me was only geology that interests me because geology I like it because you have everything. You have math, biology, because it's Earth, so you have everything because you have everything on Earth. And I think biology for me was really small things. I know you can study animal ecology, but I don't know. I used to like volcano, mountains, and I was like, "Ooh, that's so amazing! I want to know more about it, the moon, the planets." So geology seems really, it was fascinating for me. And so I've been to this preparatory class, which is, the name is in French is BCPST, because we are studying biology, geology, physics, chemistry, mathematics. So we're studying everything, and I like to do a little bit of everything because the other preparatory class, it's like only math, only physics. It's more boring for me. And I wanted to enter a school of geology, and there are not that much. There are a lot of school of biology, agronomy, veterinary school, geology not much. And so first I spotted the school of Nancy, which was an engineering school. And then by talking with the teacher, they were like, "Oh, you're good. You should try the NS." And then especially they told me that I would be paid for. And I'm not coming from a super rich family. So we are 4 children. My mom raises alone with only one wage, which is not amazing. I mean, university are paid well, but for 4 children when you're alone, it's not amazing. So I was like, okay, it's better for her if I will be independent at 20, especially if I'm going to live in another city, because we have to pay for the accommodation. And so, I mean, I was more impressed by the money that the NS would give me than by the NS itself. But it's a really nice school, and I school.
And the campus is great. I made a short postdoc there, and the campus is really great, and you have a very good environment. It's ONS Lyon, right? Lyon?
Yes.
Yeah,
And Lyon is a really nice city.
wonderful city also. But and where are you from? Where did you
Bretagne.
do your study, your
So
high school
Rennes.
study?
I'm from Rennes in Brittany
Brittany.
in English. So
Okay.
it's the northwest of France, and I was really excited to go to live for the southeast because for me it was the
Mm,
opposite. I was like, oh my god, there are mountains, there will be snow on winter,
mm,
and so yeah, I was really glad to enter ENS Lyon. At the beginning, I was like just aiming for ENS Paris or Lyon, and it was Lyon. So because geology, there are 4 ENS, but you only have geology in 2 ENS.
mm,
Ulm in Paris and Lyon.
mhm.
And I didn't have Ulm, I have Lyon. So I was like, okay, let's go for Lyon. And now I prefer the city of Lyon than Paris. So
Of
I'm
course, Lyon is the best city in the world.
yeah, I think
I'm a Lyon fan. Maybe you can little bit turn your computer, because sometimes we have, you
yeah.
got your no. Yep, perfect. You are on perfect. Okay, so you entered ENS, and in ENS, how was the study? It was a generalist study, or you can specialize very early.
Yeah, in fact, I think when I chose it, I didn't really think a lot about this. Like, it was just like, okay, I have it, I will take it, I will be paid for, it's cool, it's nice. But in fact,
Mhm.
it was really a different choice of career because I give up on being engineer because ENS, it's really science. It's, for example, the school I was aiming, like which was Nancy, it's really like geology, but about mining, about oil, about all these things, which is like for engineering science, for exploitation. It's different.
Mhm.
Industrial. It's industrial geology. And now with getting older, I know I wouldn't have liked it. So I'm really glad to have chosen ENS Lyon because ENS Lyon, yes, the lesson was really more. It was more theory about geology. It was more
Mm,
about just no industrial application. Like for
mm,
example, I never studied oil. Never.
mm,
We only studied how the Earth was formed, how the planets, the soil, and it's really just pure science. And I
mm,
like this. It's just like knowledge.
mm, mm,
And no, I really enjoyed my time there because it was like a small school with we were not that much, so we have like good quality to learn, good environment to learn, and it was really general. That was maybe the issue because it was difficult then to choose what to do because like we had like astronomy, we had like ecology, we had like paleontology, so you have a little bit of everything, but you're not getting specialized. So
mm,
that's why I did my last year. I didn't do it at the ENS. I do it in Bretagne again, and in the University of Rennes because I
mhm.
wanted to study only soil, really to specialize. Because if I'm going to do a PhD, I have to specialize, and I
And
studied
so you did your master research in Brittany, right? To get your specialization before
only the
entering
last
PhD.
year.
Okay.
I've done the graduation. Graduation
Mm.
is it how we call it in English? Licence graduation.
License is let me
Bachelor, no bachelor, yeah,
bachelor.
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 Yeah,
Bachelor
I've
is
done.
the first 2 years.
Yeah, so bachelor is 3 years in France. So I've done my
Okay.
first 2 years in preparatory classes, and then I entered the ENS, and I've done the last year of bachelor in the ENS, and I've done the first year of the master in ENS, and then for
Mhm.
the second year, I did it in Rennes. You can
Mm.
do this. You can split your master. That's weird, but you can.
Yeah, sure. Mm.
And then ENS it's in 4 years. So I've
Mhm.
done one last year but not in the ENS. It was only internship. So I've done 2 internship. So that was really nice because I could practice work before doing a PhD. So
Mm.
it's really nice things because it's something that university doesn't have. In university, you have master and directly PhD. So
Yep.
you don't have many time to think about, oh, did I like my internship? Did I really want to study this during 3 years? And to have one more year in the NS, it's really nice because you can do 2 more internship. It's like I had 3 master internship, you see. So it was more time to think about my PhD and really nice. Yeah.
Great. And how did you think about doing research? Because when you're a graduate from École Normale Supérieure (ENS), usually the royal route is to become a teacher in high school. With aggregation. I don't know if how even this diploma is named in English. It's a very particular diploma in
Yeah,
France
it was our
that
name.
opened the door for teaching in high school. So let's say nearly 80% of ANS graduates end teaching high school, which is for me a craziness, because when the nation put a lot of money to produce these elites, we want them to do science, research scientific science, and doing discovering things and doing patent and creating stuff. This is my political momentum. So, but great. So you choose to do
Interesting, but
scientific research. How this opportunity came to you, and how did you decided to pursue into a PhD, because it's not common, particularly among other ENS students.
no, PhD is quite common in the NS. No, I would say I didn't know these figures. There is 80% of people teaching.
This is my exaggeration.
I would
Because
say half.
I am from the southeast of France, so we are exaggerating.
I'm doing my PhD in Toulon, close to Marseille right now, so I can tell, yes. And I would say when I seeing my friends and I was seeing the older people or the younger one, I would say half-half, because many people are attending the contest of aggregation, but many of them are not using it after, or at least they are delaying it, and then they are doing a PhD, and they will, after the PhD, they will teaching. Many, I would say I don't have the figure, but when I see people, I would say like 80% of the students of the UNS are doing a PhD. In fact,
So it's great. It's great to hear that.
yeah, right now, but I'm not sure they will pursue in research, because many people are doing a PhD and then stop research.
Yeah.
So I don't know if they will still be scientists. But like, for example, all of my friends almost right now from the NS are doing a PhD. And no, I mean, the NS is kind of pushing you doing a PhD. Like, they have special grants. So it's easier to do a PhD when you're from the NS than from the university, because I didn't have to, I mean, I had the grant. I didn't have to go to attend a contest. École doctorale. I didn't have to do it. I had the grant. So that's really amazing, because, for example, I mean, when you're from the university, you have to, I mean, it's the scientist, your future supervisor will choose you, because he has the money and he will choose you. But in the NS, we have the money, so I
Yeah,
choose my
already.
supervisor. And for me, that's a huge difference, really huge difference. Because if things are going wrong, I will have to blame myself, and I chose him. And so that gave me more freedom for my subject. So that was really, really cool. So yeah, no, the UNS is giving every tools for you to do a PhD. They're pushing you to do a PhD. And I was not really sure about doing one, because I like science, but I'm not a huge fan of science. Like, I really like it, but it's not. I don't know. There are other things in life that I love, So I was not like 100% sure, but I had this opportunity, and I was like, so I had this freedom of choosing my supervisor, and I was like, okay, if I don't find anyone that I match with, like his personality, not only his scientific side, but also his personality. If the subject doesn't, if I doesn't feel to work on this subject, I mean, if I find nothing that really light a fire in me, I will not do a PhD. I will do something else. I was like, okay, I won't do a PhD. And then I found this PhD. I found this subject. I found Stéphane, which is my supervisor, and I was like, okay, I'm interesting. I want to try. So
So
that's why
this is how you enter into the world of research.
yeah.
So let us remind your lab, your affiliation lab. So it's in
Name
English,
is
Marine Environmental Chemistry at the Mediterranean Institute of Oceanography of Marseille, southeast of France. And your PhD supervisor, we can maybe salute them, because I see there are two, right?
Yeah, because I'm doing a PhD co-supervised between Brazil and France. So the
Oh,
one who is in France and the lab is located in Marseille, but we have like another lab in Toulon, and I'm living in Toulon.
okay.
And so Stéphane, my supervisor, Stéphane Mounier, is working in Toulon. And the other supervisor is Rosanne Marins, which is living in Brazil. She's Brazilian, and she's living in Fortaleza, which is a city in northeast Brazil. And so we can say
So I have to correct that, because on your presentation I wrote Stéphane Mounier and Christophe Panagiotopoulos. So I will correct that. You will I don't know where I found this. I think I found it on the website of your lab. So I will correct that. Just send me the right.
He's a researcher too, but I'm not working with him. But he's from the lab also, but in Marseille.
Okay, so it's a mistake. It's my mistake.
But
I will
he
correct
exists.
that. So great. What was the year you entered this PhD?
It's been 6 months now. It was 6 months and a half. It was end of October, beginning of November.
Oh, so it's quite fresh. Okay. So
I'm half of the first year.
And let me explain, because you have a dream life. Because as soon as you put your feet in the lab, they send you in Brazil, right?
Yeah, and I loved it. Well, that was kind of a bit creepy at the not tricky at the beginning, because 3 weeks after I arrived in Toulon, so I didn't even know Toulon because I'm from the northwest. I don't know many things about the southeast, and I just arrived in Toulon, and 3 weeks later they put me in a plane and said, go to see Brazil. But I was with my supervisor. I didn't speak a word of Portuguese back then. And it was only for 2 weeks to just see how is life in northeast Brazil, which is different from France, obviously. Mm. Well, closer to Marseille than to north. I mean, south of France looks more like Brazil than north of France. So I had I had a view before, and then I came back to Toulon, and right now I'm in Brazil. It's been 2 months I'm in Brazil, and I'm here for 3 months. And April, May, June in Brazil to study the mangroves.
Great, fantastic. So maybe we can start the presentation. You prepared out something to show about the mangroves, and it's really fascinating because they are literally an alien ecosystem on Earth, and very important for many things. And we'll let you explain us that. So you can share the screen if you wish. You have the bottom at the it's just like Zoom. You have the bottom to share the screen.
Okay, I will open it. But I'm really happy because I was really interested in this subject because I didn't know anything about mangroves. In fact, 6 months before, I didn't speak Portuguese. I didn't know anything about Brazil and mangroves. And it's really nice, to see just only in 6 months how I learned that much things about this country, this language, and this mangroves. So I'm really.
We don't have mangroves at the coast of Brittany, so.
Yeah, that's why I had to go to Brazil. Yeah, when people ask me why are you going to Brazil, I was like, hey, there is no mangroves in Europe. Okay. Okay, you see it?
Yep.
Let's go.
If you don't mind, I would maybe interrupt you during the presentation, maybe to ask you to precise or to popularize a little bit, some terms, so people can understand what because it's quite technical. Maybe so if you allow me to interrupt you.
Yeah. So I think I won't see you, so we have to speak because I won't see you because I will have only my presentation. So you see. Because like right now I don't see you anymore, so don't raise your hand. Yeah, interrupt me. Okay, is it good right now?
Yes.
Okay.
The guy in the water is not you, because he has a bird.
Yeah, it's the husband of my supervisor in Brazil. So I'm working with him also because they are working together, and it's really nice. Hi everybody. My name is Hélène, and my PhD subject is spatial contamination of mangroves and carbon storage in Ceará, Brazil. First, let me introduce a little bit no, because it is at the beginning we talk about that. I will directly talk about mangroves. Yes, this one. Okay. Well, I'm Hélène, I'm 25 years old, and right now it's my first year of PhD, and a PhD in France is 3 years, so I will have 3 years working on this subject. So first I will explain what is a mangrove, because it's not an ecosystem that we know in Europe, because there is no mangrove in Europe, because it's a tropical ecosystem. Mangrove, it's a word that can include else only the tree that are in this ecosystem, or can be a word for all the ecosystem, so including the soil, the animals living there, crabs, bacteria. So I will more refer to the ecosystem in my PhD, because I prefer. I'm not a biologist. I'm not studying the tree, so I will name it as the ecosystem. Mangroves are trees and species adapted to tropical intertidal zones. So intertidal, it means that this ecosystem is regularly flooded by the sea. So it's an ecosystem which is always along the coast, and the tide sometimes is rising and will flood all the sediments, all the tree, and sometimes it will not when it will be low tide. So this is important, and it can be, so it's always along the coast, and sometimes you have a river that also going through the mangroves, so it will be in an estuary, and sometimes not. But in my PhD, I'm only studying mangroves with a river, so that's important because because the water that will flood the sediments will be a mix between sea, salted water, and water without sea, river water. So water without salt, river water. So that's important. And as you can see in the picture, and you will see in the picture later, has this ecosystem is regularly flooded by the sea. It's special ecosystem. So you can see like that this tree have special roots because due to this immersion. And so why studying mangroves? Why is it important? Because mangroves represent less than 0.2% of the land worldwide. So that's kind of nothing compared to the other lands. But it's a really important ecosystem because it's a transitional ecosystem between the sea and the land. It's so I will explain point by point why it's important. First, it maintains water quality because as you can see on the picture here, with the roots, it's trapping sediments. That's one of the most important points of mangroves. Is like in mangroves where there is a river crossing mangroves. River is bringing a lot of nutrients, a lot of organic matter, a lot of things, and mangroves roots are acting like a trap. They're trapping everything that goes through, and so it's not going to the sea. It's like a place where sediments and metals and pollution and nutrients are captured. So that means that the water from the river, when it will go to the sea, will be like cleaner because mangroves are retaining things. It's also human protection for the same reason, for the same trapping reason. And one of the most important example is tropical hurricane, because mangroves are a tropical ecosystem, and in tropics you have hurricane. And for example, in India, I think it was in the 90s, there was like a huge hurricane, and you have a lot of village. And the village that were the less damaged were the one sheltered by mangroves, because mangroves just act like as a wall, like as a barrier, because it's just breaking the waves, and just it will decrease the intensity of the energy bring by the hurricane or the waves and all these things. So it's protection. It's also a place of high biodiversity because like it's a unique ecosystem, unique trees, unique soil. So it shelters biodiversity that you will find only in mangroves. Because to live in the mangroves, you have to be for the species, you have to adapt to this salty water. That sometimes there is water, sometimes not. It's really salty. There is not many oxygen because when you have like this immersion, there is not many oxygen in the soil, and it's like between sea and land. So it's really special. So we will find species that you can find only in mangroves. It also protects the protects the coast from erosion for the same reason that it protects from hurricane, because just by acting like a barrier. And as mangroves is trapping sediments, it's like, yeah, just a trap of sediments, and it's a barrier, break waves. So for this reason, it's more difficult to remove sediments from a mangrove than from a soil without trees. So it's nice, and especially with climate change, which will involve sea level rise, mangroves will diminish the effect of sea level rise. It's, well, talking about like a society point of view, it supports offshore fisheries, because mangrove is a really important ecosystem, not for all the life of some species, but at least for part of the life, for nursery, for reproduction. It's really important. Like, I don't remember the exact figure, but like more than 50% of some species in the ocean, at one part of their life, they will go to mangroves for doing something. They depend on mangroves, because mangroves, like especially the mangroves with a river that I'm studying, like you have so much nutrients brings by the river, and the mangrove is trapping these nutrients. Just fish come to feed in this area, and they know that also for the baby, for the nursery, it's a good place because it's calm, like the mangroves are breaking waves. So it's a really calm ecosystem to reproduce, to have baby, and all this thing. So yes, some species just cannot reproduce in the ocean. It's not safe. They cannot raise baby in the ocean. It's not safe. So it's really important. Even if so you can find one species in the ocean, in the deep ocean, and in fact, this species need mangroves. And there are also cultural aspects. Just considering humans, it's first just for living, it's providing woods, which is a good woods for traditional habitats. There are a lot of medicinal herbs, all these things. And also for religion, cultural, for tradition, it's important. It's just part of the culture. It's like me in Brittany. I need this beach from Brittany. I don't want people to remove it. It's part of my culture. So it's important. And last but not least, like just because it's beautiful, and we don't need more reasons to just protect the nature and protect the just animals and species.
Absolutely.
Here, I like this picture of mangroves, because here you can see why it traps things. I think it's kind of obvious how it breaks waves, how it protects from how it prevents from erosion, how it protects from hurricane. Mangroves is like, it's a nest, it's a trap. It's like everything is different. If you have no tree, no mangroves, everything will be different. Just be sea with waves, and here it's totally different. And one important thing is like, in mangrove is not soil. It's not soil, because soil, the definition of a soil is like when the rocks below the soil are getting eroded, and it's forming the soil. The soil, like the soil is from itself from below, and here it's sediments. So it's different because it forms from what the river will bring. So it's from the outside. I don't know if you understand the difference.
Sure.
Yeah, because it's really important, because I'm studying sediments. I'm not studying the soil. I'm studying sediments. So what you can see here, it's sediments. It's everything is bring by the river, by like the wind, by inputs from the outside, and it's not erosion of rocks. So that's important. And I'm studying this thing. Yeah, what you can see is the dark things, which is really smelly. You can smell it from here, but when I'm in mangroves, it's really smelly. And in fact, the fact that it's smelly, it's one of the reasons why mangroves have been destructed all over the history. It's like swamps in Europe. It's because it was known to be a smelly place, with a lot of disease, and so people used to destroy a lot of mangrove for this reason, because it seems unsafe. And so now I'm going to talk about the threats. There are, of course, many threats to mangrove forest. In Brazil, urbanization is important threat, because in Brazil, all the big cities except Brasilia are along the coast. It's like, the inland of the country, there are not that much people living, because it's the climate really hard, different. and it's easier to live along the coast. But along the coast there are mangroves, so mangrove has been destroyed to build city. Also, mangroves are threatened by all the pollution inputs due to industrialization, due to agriculture, and shrimp farming. Shrimp farming is also really, because in Brazil, it's a country that produces a lot of shrimp, and shrimp need mangroves to grow. The shrimp farming are close to the mangrove because they need this kind of ecosystem. But shrimp farming, to grow the shrimp, we are putting a lot of nutrients, but too much nutrients. And then when, I don't know if you know how works shrimp farm, but they fill the basin with water from the mangrove. And then when they want to collect the shrimps, they will remove the water and just the water will go back to the mangrove. But it's not the same water, you know. They have put many things inside. So that's why it really damaged the mangrove. That's why. And in fact, I have a picture. I forget about it because I take it recently, but you will find it interesting. See what shrimp farming are doing to mangrove. It's here. You see? Do you see it? Yes.
No.
You don't see it right now. Maybe I will have to. I can do because I take this recently.
Maybe you can try to share the screen with the new.
Try. Okay. Yeah. Here. This one. You see?
Yes.
So
you need to double click on the image.
I did, but that's a sharing screen. I'm not very good at this. Yeah, I will. I think I will just share my screen. In fact, because now you could see every. Okay, I think now you see it.
Yes, exactly.
Okay, so that's a mangroves damaged by shrimp farming, because the water released by the shrimp farming will be rich in nutrients, but too much nutrients. We call this eutrophisation, and it's like, so it's not good for the mangrove. It's not what they are used to. So below you can see healthy mangroves. Behind you can see a healthy mangroves. You see more green. And this is close to a shrimp farming, and we see like the mangrove is dead. I love this picture because you can see everything, healthy mangroves behind, and this one which is just dead. So that's in Brazil. I took this picture a few weeks ago, and that's in Brazil, and it happened.
It's impressive, and there is a shrimp farm in front of the dead area, right?
You cannot see it because it's difficult, but it's like basin, lakes, and it's like just the other side of the river. You have the shrimp farm. And I collected sediments, so I will study the sediments of this area. So I have no result yet, but I will study this spot and compare with the healthy mangroves to see what is the difference in the sediment.
Okay.
Yes.
So I reshared your slide deck.
Okay. You see it now?
Yeah.
Okay. So shrimp farming, and in Brazil, so I don't really know worldwide because I'm studying only Brazil, but in Brazil it's really one of the most reason why mangroves are threatened. So you can stop eating shrimp if you want. But no, it's a joke, but it's really a problem here. And other issue are like damming, because damming is just for, like me, I'm studying mangroves with a river, and when you have a dam, the inputs are different, the water flow is different, so of course it will change how the ecosystem is working. And well, deforestation, obviously, you know why it's a problem. And tourism, of course, because if you have too many people working in the mangroves, if you're putting stairs, so you want people to enjoy more the mangroves. Well, mangrove is not a place for tourism. It's difficult. It's like impossible to. So yeah, this led to at least ecological disturbance or eradication. I mean, if you have deforestation and contamination, which is a point that interests me because it's something contamination. It's something you cannot really see, except for the shrimp farming. But you cannot really see contamination, but it exists and it has an impact on all the life of the mangrove. So this is what I'm studying: spatial contamination of mangroves and carbon storage in Brazil. So contamination, I'm focusing on metal. You can study other things, plastic, other things, but you have to choose. So me, it's metal.
So
Metal that
maybe there is also another point to say why studying mangroves is important, because it's in your title, is carbon storage. You didn't mention it into the point, but what I learned about it is that the mangrove can capture and storage third more time or even more CO2 than the tropical forest
yeah,
of the inland,
yeah,
of the Amazonian inland. So it's very impressive.
yeah. In fact, yeah. It's I didn't mention it, whereas effectively it's obvious for my subject, but yeah. Indeed, mangroves with the actual context of trying to reduce carbon emission. Yeah, mangroves can capture a lot of carbon, and that's
Mm.
the point of my PhD, to study to study how pollution will change this carbon storage, or and yeah, in fact, it was one of the most important point. So
Sorry, just to continue on this point, because it's very important. I have some kind of funny debate with other scientists, and they say that the emission of CO2 is a major issue, etc., for climate change. And people like me who are a little bit fun say, okay, just let plant some trees. But I say it on a joke way, and usually they tell me, okay, but it's not enough. It's inefficient to cap the production of CO2. But what is interesting here, that is the mangrove can actually be a solution. If maybe one day we can even, I don't know if it's possible to plant, to seed mangrove, and but this is another discussion. But it could be part of the solution.
yeah, actually, in some countries such as Southeast Asia, they are doing some campaign to plant again mangroves, to
Mhm.
reforest mangroves. Yeah, to get back all that good thing that mangrove used to bring. So yes, and yes, I mean it's better than nothing. But
Mhm.
scientists will always say many things. For me, everything is better than nothing, and also, well, that's another debate. But all scientists have their own point of view,
Mhm.
and also it's not because they are scientists that why they are saying is true. They are still human beings. They are not objective. Nobody can be
Mhm.
objective. Nobody is natural. So sometimes I'm just for me, planting tree is still better than nothing. Well, one point that is true is like it's not the same thing. Planting again will never restore what used to be. For
Mhm.
example, in Brazil, a girl asked me, "Oh, but Amazonian forest, if you are destroying it and then planting again, will be the same thing." And I was like, "No,
Mhm.
this forest is like really old, and you don't have the same property in old forests. In 1,000 forests doesn't have the same." Does not function the same way than a young forest. Especially for
Mhm.
mangrove, it's true. When a mangrove forest is like 100 years old, it's not the same property of storing carbon, of the soil, the sediments is not the same than of
Mhm.
mangrove forest, which is like 10 years old. So
Mhm.
that's the issue of planting again. But it's still
Mhm.
better than having no tree. It's still better. So
Absolutely.
it's, yeah, I mean, it's just different. Because just a little bit talk about this. Funny things like in all people studying pollution, when you hear people studying pollution, they will all say to you that they are studying that the pollution they are studying is the most important. Someone studying plastic will say, no, the real problem in the world is plastic. The one studying mercury will say, no, it's mercury. And I would say, no, it's carbon emission, but well, just, it's human.
Yeah, absolutely.
Yeah, I'm not saying that mangrove is the best thing on the world. It's just like the thing I'm studying, so that's
Mhm.
enough for me. And so this point about carbon storage, especially about my PhD, is like the hypothesis. The main goal is like there is global warming, so the sea level is going to rise, mangroves are getting eroded, and so what is going to be lost? I mean, we're going to lose sediment in the sea. What's going to happen? Are we going to lose a lot of carbon? Are we going to lose a lot of pollution, metal? So that's the goal of my PhD, trying to assess what is downstream the mangrove, what is upstream, to know what we're going to lose. So you can see here on this nice drawing, downstream. So this is a mangrove with a river. You have the river, you have the sea, you have the tide going along the river when it's high tide. And you can divide the mangroves in 3 points, downstream, middle, upstream. And I'm studying sediments and organic matter along these 3 points. And my hypothesis is like, I hope, I will see, that if I think there is a difference of organic matter. I think the mangrove is not the sediment of the mangrove. I think it's not homogeneous along this gradient, because here you that's the hypothesis. And I think also that if the organic matter is different, like organic matter is known to complex with metal, is known to retain metal. So I think like if we have a different organic matter upstream and downstream, we have a different capture of pollution. So I wonder, are metals, are there more metal here? It depends. It depends on the organic matter. So that's my PhD. And my PhD is supervised in Brazil. So you have mangroves in Africa, in South Asia. You have mangroves everywhere in the tropics. But I'm studying Brazil. And I'm in the laboratory that's in Ceará, which is northeast Brazil. So you see this part of Brazil. And my laboratory is located in Fortaleza, which is the main city of the state, the federal capital of the state. Fortaleza, here is Fortaleza, a nice picture I took. We have like amazing sunsets each day at 5 p.m. because it's tropics and the sun sets always at the same time. And Fortaleza is the 5th biggest city of Brazil, so it's important. It's like 2,500,000 inhabitants, and it's sheltering inside the city. It's sheltered 1.5 hectares of mangroves. So there is a human impact on this mangrove. Obviously, you have 2 million people living around this 1 hectare of mangroves. So of course there is a huge impact, and I'm studying this. How I'm going to do? Well, I'm studying 3 mangroves. I will introduce them later. 3 mangroves that are different. Humans have a different impact on these 3 mangroves. So I will compare this impact. And so I'm studying the organic matter and how. First, by collecting organic matter in sediments upstream, middle, downstream on each mangrove. But I'm studying also at different depths. That's important because, sediments in the mangrove, the depth is like more than 1 meter. So I'm collecting at different depths because I also want to see some temporal evolution. Because, for example, if I remember well, but like 1 meter of sediments, it's hundreds of years, So I can have like an historical evolution to see how pollution evolves and to see, just a profile. Because if I'm studying only in surface, it's like only studying 1 year of the mangrove's life. So that's not really interesting. And then I will, in the laboratory with the instruments, I'm studying carbon, nitrogen, sulfur contents. I can also with techniques like fluorescence. I can describe more organic matter. I can say what kind of type is it. Is it like aromatic organic matter? Does this organic matter come from the land? Come from the ocean? Comes from bacterial? Like you can do a lot of things just with all this funny scientific stuff. And the other point is characterizing metal presence, which is different techniques, and studying the complexation. To describe more Brazil, because it's really important for the mangroves and for my field trip, because when I'm coming to Brazil, I'm coming in different season. So Ceará is tropical climate. So it's like 2 seasons. You have a rainy season between January and July. So for example, today I'm going to walk by walking, and it was raining. So I was like, yeah, I get wet going to the walk. And then you have this dry season where like there is no rain from August to December. So this is really important for how the mangroves will work, because even for the sediments, I think you can see. I don't have all my results yet, but I think you can see through the season. You can see an evolution in the sediments. For example, when it's the rainy season, you have when it's the rainy season, the river, you have a lot of inputs because the river is like bigger, you have a lot of water, so you have a lot of sedimentation, a lot of inputs. Whereas when it's the dry season, you have how can I say, the ocean will be more important because the river will be smaller, so it's the sediment bring by the ocean that will be more important. Another effect of this dry and wet season is like when it's the dry season, the sediments are drier, so there are cracks in the sediments. So oxygen will penetrate deeper, because when it's a wet season, the soil is really wet and it's really like drawn. When the soil is drawn, you have no oxygen. It's reductive condition. It's really different. So you have no oxygen, so bacteria will live differently without oxygen. It will be a different metabolism. It will be different. And then in dry season, you have oxygen. So mangroves during the year, you have different way of functioning during the year in mangroves. And then climate change, how it is evolving here. Well, first, also funny things, and I really sometimes don't understand human. It's funny because when I'm talking with Brazilian, some people will say, "Oh, it's been years that it's raining more and more and more," and others will say, "Oh no, there is no more rain." So when you talk with people, you don't know. Like sometimes they will say to you, "There is way much more rain than it used to be," and sometimes they will tell you, "There is no more rain anymore." So, well, you have to study the fact, like neutral, so not listening too much human, but just seeing the evolution with the data we had. It looks like it's decreasing, and of in average 5.3 millimeters per year. But I think it's important to consider. But you see this graph. This graph is like just data from Meteo. But it's only from 50 years old. This is not a long-term study. I mean, climate, you don't talk about climate in this small area, you see. When you talk about climate, it's 100 years old at least. I mean, Meteo is daily, annually, but climate, it's for more years. And for me, 50 years old is, you can talk about climate. So that's complicated. Also, you can see there is like huge variability. For example, the year 1986 was the most rainy year in this from 1960 to 2005, you know. So that's the process. It's an average. So there is a high variability, and also an important point in South America. South America is strongly influenced by El Nino, which is a meteorological concept about linked to Pacific Ocean. It's complicated. I won't explain right now. I'm not even sure we'll know how to explain. But El Nino is like Gulf Stream, you know, in Europe. It's an important meteorological thing. And currently, people don't know how El Nino will evolve with climate change. It's really difficult to predict. It's really unstable. And El Nino is driving climate in Ceará as well. So you cannot forecast how climate will evolve in Ceará if you don't know how El Nino will evolve. So that's difficult to really forecast how things will evolve. Also, this is in Ceará, and Ceará is big. Ceará is, I show you, I mean, in the map, for example, if you want to cross all the states, it will take you more than 10 hours. So Ceará is big, it's like France, you know. So it's hard to assess one climate only in the Ceará state because, for example, also there is a huge difference between the coast, the climate along the coast, and the climate inland. And mangroves are along the coast, and so that's difficult because you have like some local effect. For example, so yeah, right now I think we cannot tell if the rain is decreasing. It's hard to say. And so here are the 3 mangroves I'm studying. So the name is Rio Coco, Rio Pacoti, Rio Jaguaribe. And so difference between these 3 mangroves. Rio Coco is really inside the city. Like you have a supermarket in the mangroves.
Wow.
Yeah, that's the main point. So it's really inside the city. And but you have the tree and it's beautiful. I mean, it's a mangrove. And the main impact is the city, sewage input, city influence. Rio Pacoti is more outside of city. It's like in the in the side of the city, so it's less impacted. From this 3 mangrove, it's the kind of the most cleanest one. And then you have Rio Jaguaribe, with it, not in Fortaleza. It's like close to, for Brazilian it's closed, for French it's not closed. It's like only 3-4 hours from cars, So, but it's still close to Fortaleza. And the main impact is the shrimp farms. So the picture with this forest, with this shrimp forest, I show you, has been taken in Rio Jaguaribe. So the main impact is not city, is like farms, agriculture, shrimp farms. So I will, studying 3 different mangrove, I will study 3 different contamination. I will show you quickly in this presentation my first result. I've done a field trip when I was in November, when I was in Brazil in November 2022. I've done a field trip where I studied only Coco River and Pacoti River. I didn't yet, back then I didn't study Jaguaribe. Jaguaribe I studied it in March, so that's different. And I was in Brazil during the dry season, so that's important. It was a dry season. Right now, I'm in Brazil during the wet season, so I will then compare this season because I did other field trip. So you can see the mangrove. So you see Coco River is really in the city. It's like crossing the city. Whereas Pacoti River is close to, but it's not crossing the city. The river is coming from further, you see?
Mm.
So different impact. How did I conduct my field trip? So I just collect sediments. So just in bag, I collect sediments at the surface, which is like between 0 and 5 centimeter depth. And then more in depth, I dig and I collect sediment at 20 centimeter depth. And so at 3 points, downstream, middle, upstream. And I also sampling the river water to study both sediment and river. And then I've done analysis, so carbon, nitrogen, sulfur, which is like organic matter elemental composition. And then I've done fluorescence and UV spectrometry, which is like technique that using the property of organic matter regarding light. I won't explain it right now because I think it's not that much important, and that organic matter has properties, and if you can know more about organic matter if you use these techniques about how it will reflect light, how it be, how we will have fluorescence and all these things. So it can allow me to have more accurate analysis to specify the type of organic matter. It's just to be more accurate. So here are the first results. So you can see to the left, Coco River. To the right, it's Pacoti River. So careful, it's not the same scale. You see, Coco River range from 0 to 30% of total carbon in my organic matter. Pacoti River range from 0 to 7. So I put the line here of Pacoti maximum carbon content, you see? So you can see the river upstream has way much more carbon, see? When it's full, it's at the surface. When it's like these things, it's like in depth. Upstream, middle, downstream. So the first thing we can see is like there is an abnormal content of carbon here upstream for Coco River, because the average for healthy mangroves is 2%. So Pacoti is kind of normal for upstream and middle at both depths and surface. Downstream it's a little bit higher, but can be normal. I mean, it's an average. But definitely this 15% of total carbon, it's not normal. It's not natural. See, so there is a pollution here. And I think it's due to this city sewage, because there is not a real treatment of sewage in Fortaleza. So it's just all this carbon due to human organic matter. Here. Then another really important point is like you have a different dynamic of carbon, because you can see that for cocoa mangrove, carbon is decreasing when you go back, when you're going closer to the sea. So you have less carbon downstream than upstream. And for Pakoti, it's the opposite. So that's really interesting for the sea river rise and erosion, because it means that Pakoti will be more affected by the erosion, because you will lose more carbon for Pakoti than for Kuku. See? So that's an important point for these global change things. And last things is like if we're comparing between surface and depth, you can see that with these error bars that it's not really significant, the difference. For Pakoti, you kind of have the same amount of carbon between surface and depth. So that can mean different things, but for me, maybe it could mean that there is a slow decomposition. So that's the carbon storage. Because if you have the same amount of carbon at the surface and at depth, it means that there is not a huge bacterial decomposition. Or at least if there is, you still have carbon in the mangrove. So there is a carbon storage. So that's really interesting. Except for cocoa, whereas like you have this amount of pollution in the surface, and then in depth you see, so there is a huge decomposition between surface and depth, which means that this pollution, this carbon brings by the human, is easily decomposable, which is a characteristic of this organic matter coming from sewage. So that's kind of logical.
So maybe I'm going too far, and you're surely talk about it. The source of this carbon is it maybe fecal exflue of the city or something like that? Or
I think so. I think it is. I can tell by the smell when I was in the mangrove, but I think it's not only this, but mainly because there is sewage inputs. I don't know yet what is the part of this sewage input, but there is definitely this fecal, from toilet, from everything, from Fortaleza, and especially because this, fecal is really easily decomposable, so that would be logical. But I think there is also input from industry, from other things. So it's a little bit of, but I think it's an important part of sewage, which is like really just linked to human inputs. Yeah. Then I plot this graph, which is so when people are studying sediments or soil, it's really common to study the carbon and nitrogen ratio, because it gives us two information. First, the origin of the organic matter, because you have organic matter, but the ratio of how much carbon you have comparing to how much nitrogen will give you information. For example, amino acid in English, which is like proteins and all these things, linked to proteins, you have a lot of nitrogen. So we have a low C/N ratio. If you're studying wood, like lignin, which is a chemical product of wood, there is a lot of carbon. There is not much nitrogen. So if you have organic matter with a high carbon nitrogen ratio, it would be more like lignin, woods, these kind of things. If you have organic matter with a low carbon nitrogen ratio, you will have more nitrogen, and it means more like bacterial, amino acids, proteins, small molecules. So it's really important because you can easily know what kind of organic matter you have. And so I plot this graph, which is this ratio, and it's in surface comparing to depth. So you can see the river here, you can see cocoa sediments here, and Pakoti sediments here. Also the C/N ratio will give you another information, which is a decomposition state. Because when you have organic matter, first you have in the organic matter, you have carbon, nitrogen, phosphor, sulfur. But then the bacteria, they will decompose nitrogen and all these things. So when the organic matter is getting older and older and older, you will have more and more carbon. It will get richer in carbon. So through times, the C/N ratio, the C over nitrogen ratio, will get higher because it will get more rich in carbon. So if you have also a high carbon over nitrogen ratio, it means that the organic matter will be older. For example, petrol, oil have a really high carbon over N ratio because petrol is a really old organic matter. So that's two important information. And what we can say about this plot is like, first, we can see that cocoa has a lower carbon over nitrogen ratio, which means that the organic matter of cocoa is relatively richer in nitrogen than pacotille. So it's important because we have seen that cocoa mangroves has more carbon, has more organic matter, but carbon organic matter, but relatively it has more nitrogen. So it's not the same quality of organic matter we have between pacotille and cocoa. It's definitely not the same. The carbon pacotille is relatively richer in carbon, so pacotille has a better carbon storage regarding this. And this is also linked to these sewage things, because the organic matter in sewage is richer in nitrogen, in sulfur, and less in carbon. So that's coherent, that's consistent with this sewage input. Also, if you are regarding the river, we can see that Cocoa River has also a C/N ratio lower, and Pacotille River has a C/N ratio higher, which means also that organic matter is likely bring by the river. Could be bring by the ocean, could be bring by the winds or other thing, or just by the soil itself. But I would think it's bring by the river mostly, this organic matter. I would say this. Looking at this graph. So that's the first important point. And we can also say, when we see this graph, for example, you can see that this line represents, if points are along this line, it means that there is no evolution between surface and depth. Because this line, the equation is y is equal to x. So it means there is no evolution. You can see that pacotille, the points are along the line. So we can see that for pacotille, there is no evolution of this ratio through depth. So if there is no evolution, because this ratio is linked to decomposition, so if there is no evolution through depth, it means there is not a high decomposition in pacotille through depth, at least between 0 and 20 centimeter depth. So there is two hypotheses. Hence, the degradation is slower in pacotille, so which means that bacteria won't decompose it really fast. Else, it can also mean that just there is not many variation of inputs of organic matter. Because for cocoa, there is a difference between surface and depth. But it can mean that, for example, because the organic matter that we can find at 20 centimeter depth, it's the organic matter that this organic matter lay in the sediments like 50 years ago. So it just also means that 50 years ago it was a different organic matter. I'm not sure if you have the point. If I'm explaining.
Yes.
Yeah. So yeah, it's difficult to say. Is it a difference of decomposition, or if it's a difference of just a source at the beginning, that the organic matter was not the same, or there is variation through the years. And this, I think I could assess this with further studies. I can have the answer, but I need more analysis to have the answer. But at least we can say that pacotille, there is not much evolution right now between 20 centimeter depth and 0 centimeter depth and surface. And also, I can plot this graph because with other research, people have assessed like typical ratio according to where the organic matter comes from. So if it's algae, if it's marine organic matter, you will have a ratio between 0 and 10. If it's like a mix between marine organic matter and terrestrial organic matter, you will have a ratio like this one in pink. And if you have a ratio over 20, it will be mainly terrestrial plants. So this is interesting because you can see that pacotille, especially downstream, you have a higher contribution of vascular plants, which means that organic matter mainly will come from the mangrove itself, will be just the decomposition of the mangrove itself, of the leaves, of the wood. But for cocoa, it's more a mixed, which means that you will have a mix between organic matter from the tree, from the leaves, but also from what is bring by the ocean. Algae, ocean is bringing a lot of things. So this graph just show me also where does the organic matter comes from. Then I also plot the carbon over sulfur content, which also give us information. It's the same idea. Also with all the research that scientists have done, you can see that, for example, if the ratio is over 18, it's more like fresh water. There is not many sulfate. If it's brackish, means that it's like not a clean water, that it's kind of not really clean. Yeah, in French is saumâtre. So it's not really clean water, which is typical from mangrove. You can see like typical mangrove ratio are this one in this color, and because it's brackish water with a lot of saline influence due to the sea. So you can see that most of the points belong to the typical mangrove ratio, except this point really polluted in cocoa. So here, I think it doesn't mean that it's fresh water. It just means that this point is not natural, because this plot is correct only in natural condition. This point is not natural, so it just confirms that it's pollution. So yes, pollution. Yeah, we can also see that pacotille, just as for the carbon over nitrogen ratio, pacotille ratio is higher, which means that the organic matter is richer in carbon. So to conclude, you can see that organic matter of pacotille is really rich in carbon. There is not much sulfur, not much nitrogen. Whereas cocoa, there are way much nitrogen and sulfur. Which means that the organic matter of cocoa will be also more easily decomposed, because it's easier to decompose these kind of nutrients, metabolizable. And also you can say that the points, they are not along the line, so sulfur content is really variable through depths. So right now I cannot really tell more about this, but just I know that sulfur is something that can really vary, that can really change along the depths and along these downstream, upstream gradients. So yeah, mangroves are known to have a lot of sulfur. That's why they are really smelly. That's why people used to not like it, because it smells like eggs, when you have sulfur. That's really hard to work in mangroves. It's really smelly. And so yeah, it's important to study sulfur. For example, you won't study sulfur in an agricultural soil, or not much, because it's not that important. But in mangroves, due to the special condition of this reductive environment with the water, with the sea, you have a lot of sulfur. To conclude, so after, that's my first result. So you can say that I've studied two mangroves, and we can already say that they have opposite dynamic, because carbon is accumulated upstream for cocoa and downstream for pacotille. So that will have an impact about this erosion things. We will lose more carbon in pacotille mangroves with the sea level rise. Also, cocoa has higher content of carbon, mainly due to pollution. But this carbon is a different quality from the carbon of pacotille, because the organic matter containing this carbon is like richer in nitrogen and sulfur, which is totally different, because it will be less stable. Because when you have only carbon, it's really stable, because bacteria doesn't like it. But when you have carbon and nitrogen and sulfur, it's not stable. So I think the carbon storage is less efficient in cocoa mangrove. You see, it's really less efficient, because bacteria like this, and it's different. So yeah, and talking about this depth gradient, through depth, pacotille organic matter seems to be more stable than cocoa organic matter, which is likely linked to this nitrogen and sulfur things. And and also this is different, because that's the subject of my PhD. it's spatial contamination. So we have seen that we have a difference of organic matter along upstream, downstream gradients. So then, then when I'm going to study the metal complexation, I'm expecting to see a difference of metal complexation because I can already see there is a difference of organic matter quality. And it's known in science that if you have a different organic matter, you will have a different complexation because metals are complexing with different groups of organic matter. So I can already tell that I can expect that between upstream and downstream of the mangrove, I will have difference of pollution retention and all these things. So that would be interesting. So, yeah, the main point is this carbon storage, and that Pakoti is storing more carbon downstream and it's richer in carbon. So I will study this in my PhD. And what now? E agora? No Portuguese. That means what I'm doing now. So I've done a field trip in this other mangrove, Jaguaribe mangrove. So where is this picture? So in fact, I put it. I forgot that I put it. So you can see here a picture of the sediments. That's why I'm collecting. So the first one is downstreams and middles and upstreams and shrimp farms. So you can see that the color is different. So you know they will have difference of contamination and of organic matter because just seeing by the eyes it's different. So I sample sediments, and this time I have more depths because my first field trip I had only 0 and 20 centimeter depths, but here I have like all the profile ranging from 0 to 80 centimeter depths. So that would be interesting to have more points and have a proper time scale. And also it's a different season because now it's a wet season, so it would be interesting to compare with my first analysis of the dry season. And yeah, I will pursue my studies and have the metal assess the metal presence and complexation. So that would be interesting. Yeah, I'm done. Thank you.
Thank you, Hélène. It was great. Thank you for your talk, and it was crystal clear. And thanks for the popular way you expose your research. It was very easy to understand, very
Yeah, I
important.
hope so. That's nice, because that was the point. Yeah.
Maybe I will stop the screening, but first of all, I apologize. You don't see me now?
No.
Okay. I have lost my camera. I don't know why, but it's the magic of. Okay, but I'm here. Don't worry. I have some question. First, is your way of investigating this pollution? Is it something that you develop with your lab specifically, or is it something standard to study the pollution of all mangroves around the world? Because my question is because there are many other science groups who are studying mangroves in Philippines, in India, or I don't know elsewhere, and maybe they can see you and maybe they can apply your technique for themselves, or they already using your techniques.
Yeah, honestly, I'm using really easy techniques like right now. I don't know yet because it's still the beginning, but right now, just collecting sediments in mangroves. That in fact that's why I choose mangrove because the good things in mangrove is like it's so rich in carbon. It's like so dirty, rich in carbon that you don't need to have like a really clean protocol. I'm explaining. For example, in my lab, most people are studying the ocean, but the ocean, you know, when you see water, well, water from the ocean is way more cleaner than the water from the mangrove. So you have to be careful because there is a huge issue of contamination in the ocean. If you want to study properly carbon, you have to be very careful. Everything must be clean and all these things. And so you need to have like a protocol which is more strict, more more important, more heavy. But me in mangrove, that's a good thing. You just have to collect it. You don't care about if it's clean or not because mangrove is so full of carbon, so dirty. That's the good point. So I don't have like my way to sample mangroves is quite easy. And then back to the lab. But when I'm reading paper, most people are doing this. In fact, they are just collecting sediments in the plastic bag, and then they are the thing that will be different will be then the extraction. You have organic matter, you have to extract it from the sediments. So you can extract it with water, with acid, with bases. It depends what kind of organic matter you want to study, what kind of chemical groups you want to study. So that's the difference. But for what I'm studying, I'm using kind of classical method. There is like nothing new. I didn't develop anything. I'm applying what was already found in the past.
So just to follow up on your answer, did you see in the literature if other mangroves around the world have also this tendency to be polluted by human activity, or is it
Yeah,
something
yeah,
particular of the Brazilian
yeah. No,
ones?
no, no, no. Almost all. It's just polluted by different things.
Mm.
In Brazil, it's really shrimp farms, really, because for
Mhm.
example, you have mangroves in the Caribbean, and I think there is not much shrimp farms in the Caribbean, so they won't be polluted the same way. But they will be polluted by plastic. They will be polluted by metals, because if you have like an industry of, I don't know, coppers creation, coppers industry, you will have pollution of metals. It really depends what is close to the mangrove. I know that Asia has a lot of problem with plastic, and yeah, yeah, it really depends. It's really local, but
Mm.
most of them are polluted.
But there is a tendency that we saw everywhere.
Yeah, for example, I know that Africa, it's also with heavy metals like
Mm.
mercury, copper. Yeah, Africa has problem because they have a lot of mines and all these things. For example, for them, it's more this thing.
There is also this interesting thing that the vegetation, the plants of the mangrove are so strong, and so resilient to
Yeah,
pollution that maybe and people think they are kind of sponges, so they can pollute high amounts. So this vegetation will capture everything, and they will be fine. But you show with your great photo that just a shrimp farm can kill them. So it's not so they are not so strong. In
yeah,
fact, they
they
are
like
quite
humans. They
fragile.
have limits.
There are limits, yeah. And what about? I have a question also. It's just for my, let's say, for my intellectual curiosity. Do you think that we can trace the precise source of the pollution you study by organic chemistry analysis, such as RMN and other techniques? Because this carbon that you showed that it increased in some part of the mangroves. Maybe we can find exactly what kind of molecule it came from. Do you think that is possible or not?
Yeah, I'm sure it's possible because in my previous internship, that was my subject. I was working about tracing organic matter and metals,
Hmm.
and I did it for soil in India and uranium. Like for example, yeah, you can, if you have a rocks with uranium, you can more or less know in what kind of country it comes from, because like you have this technique in geochemistry, which is because you know what is an isotope. And I don't know if I have to explain again what is an isotope for people listening, but
Uh, yeah, no, don't enter to the explanation of an isotope.
okay.
It's,
But using isotope, you can, because isotope have a specific signature if you studying ratio of isotope, and you can know where everything comes from with isotope. That's a good thing.
absolutely.
So you can, because for example, you think that this industry is polluting this site, so we will take a sample of what they are producing, and you will study the isotope, and then we'll compare the signature with what you find in the mangroves, and you can know if it comes from here or not. Yeah.
Because you surely understand why I'm asking this question. Because if we can identify the exact source of the molecule that contribute to this carbon pollution, you can then make some policy, uh, etc., and say, "Hey guys, stop doing this," or maybe try and find solution. But my
Yeah.
question is it a kind of general pollution? Many type of carbon many type of organic molecules contribute to this carbon pollution, or maybe it's a couple of molecules from precise source. As I said in my previous question, about the human efflux.
Yeah. I mean, it's kind of obvious where the pollution comes from, because, for example, Ryokoku, it's in the city. So you know that it's these sewage things.
Mm.
And Jaguaribe for the shrimp farms, you know, it's a shrimp farms. Like it's not a local pollution. It's like big. Like you can see all the shrimp farms next to it. And the issue in Brazil is not to know where does it come from. Everybody knows where it comes from. I mean, it's been 2 months I'm here. I know where it's come from. The problem is then to the law. I mean, problem is not nobody. I mean, this is the problem. Like we all know that shrimp farms are killing mangroves, but just agriculture, especially in Brazil, well, in France also, but especially in Brazil, has so much power that right now I think it's too soon for people doing. I think in the future there will be law. For example, it's interesting because this week in Ceará, a new law has been applied. Like now it's forbidden in the state to pulverize toxic products for agriculture with plane. It used to be legal until this week that you have plane just pouring products on the land, and it's illegal from now. So things are moving. That's really good. Like they're doing more and more things, but it takes time, and yeah, it's politics. It's not science anymore.
And just to remind the importance of this mangrove and the destruction of the mangroves, so the in terms of kilometers at the coast, what is the percentage of the mangrove destroying by human or directly or indirectly? Do you have these numbers or?
It's difficult to assess how much we have lost since the beginning because mangroves have. It's not recently that people are destroying the mangroves. It's been really a long time because it's like swamps. You know, in Middle Age in Europe, we have destroyed all the swamps because it was like a place of disease. So it's been like 1,000 years, and I mean, since human exists, they are destroying mangroves. No, they are using it, but a lot of people just destroy it because it was like a place of mosquito, of disease, and all these things. So we cannot really know how much they used to be. Well, right now the good news is like there are many places where you have more mangroves than you used to be 100 years ago. Because, for example, in Brazil, even in Fortaleza, the mangroves I'm studying now, they are bigger than they used to be 50 years ago. Because they are growing them again and all these things. But it's difficult to assess. But a lot of mangroves has been lost. I would say, like when you say, I think I have for Asia figures. Wait, if I have a figure, and yeah, I think it's really. If I'm opening my PhD, because I'm, and what I wanted to say about mangroves, yeah, but also things to know is like mangroves are not going that much inland because mangroves are depending on the sea, so it's really a coastal. So at the beginning, it was not a huge ecosystem. It has never been a huge ecosystem because it's really.
But what is fascinating with mangroves compared to the internal tropical forest of Amazonia is that when you destroy the Amazonian forest, it takes 1 million years, to recover. But mangroves have a higher turnover. They can.
Yeah, that's for example, I have an but that's the good things about mangrove is like it's growing really really fast. It's growing really fast, and but still you don't have, as I told you in the beginning, you don't have the same property of a mangrove forest, which is like 200 years old, and one that is, even if it's growing fast, it's not the same mangrove that you have back.
Yeah, it's so juvenile, and it's not the same that were there. And produced from 100 years or 1,000 years, so of course it's not the same.
Yeah, but I mean, Amazonia. If we're losing Amazonia, we'll never have it again. That's sure. You will have mangroves again. That's the main point. So I have a figure. By the early 19th, 50% of the mangrove forest.
I don't see it.
Okay, so I will read it.
Okay, sure. Okay, sorry.
By the early 90s, 50% of the mangrove forest in Thailand and 21% of the mangroves in Ecuador disappeared because of shrimp ponds. Wow. So you have half of the forest in Thailand and 20 in Ecuador. This was in the 90s. Well, I know that now in Thailand they're going to do some forestation again. So now you have a little bit more than used to, but yeah, half of them. And shrimp ponds, so shrimp farms, de novo, again.
Okay, this shrimp. It's fascinating. And what about the future? So what are you said me at the beginning of the talk that you will come back to Brazil, right?
To France, right now I'm in Brazil.
Ah, right now you're in Brazil.
Yeah, right now
Okay,
it's like
I thought you
1
were
p.m.
in.
and a half, and I'm super hungry.
Okay, well, thank you so much. It was so great to have you and for your explanation. I really loved your presentation, very clear, and I think many people will like it, and we maybe contact you to discuss with you. So you don't have yet a LinkedIn profile, so I advise you to make one, because there are many people out here who can be interested by your work and contact you. So I will of course share all your let's say official link to the lab, etc. So people, if want to contact you
Yeah,
with
yeah. I mean, with my mail of the lab, people can contact me.
yes, of course. Thank you so much for being my guest, and it was really a real pleasure to have you today.
Yeah, and thank you. For me, it was also nice because it's allowed me to make like you know make like how can I say, like, to just make things clear for me as well, because it was like doing a resume of my work. Yes,
Yeah, it was crystal clear. Thank
put
you
it
so much.
aside.
See you soon. Bye.
Bye bye. Thank you.